So we're back to doing our SBAC review, day 9. The topic is on Algebra and Functions 2. Okay, so our first question is number 7. A student has a saving account with X dollars in it. The student plans to withdraw T dollars each month after N months. Enter an equation for the balance, Y, in the account after N months. So our balance is Y, and we're start out with X amount of dollars, so we give it an X, and we need to withdraw T dollars, so withdraw means a minus T, and each month, so that times by N. So our equation is Y equal to X minus Tn. Number 8, Anthony plays a ball toss game. He stands at a starting point and throws the ball into a basket 12 feet away. The height of the ball, perpendicular distance from the ground, is a function of the horizontal distance from the starting point. The table shows the relationship of the height of the ball and the horizontal distance from the starting point that the ball has traveled. So then, in order to first answer those 3 bullet questions, we need to understand the table first. Right? So in saying that we will start out at 0 distance from the starting point, then the height is 3 feet. And if we move away to 3.5 distance from the starting point, then the height will be 6.78. So we know that as we move away from the starting point, our distance increase, but then we hit 8 feet is our max, and after that, the distance will decrease. Right? So determine whether each statement is true. Write true or false for each statement. The highest point reached by the ball is 8 feet. So from here, we look at our table, that's the height is 8 feet. So the answer is true. The starting and ending heights are equivalent. So this is our starting point, and this is our ending point, and the height is 3 feet and 3 feet. So this is also true. The height of the ball decreased from when the ball was at a distance of 3.5 feet from the starting point to a distance of 6 feet from the starting point. Well, to go from 3.5 to 6 feet is here, and we know that this from 6.75 to 8 feet, that's an increase. So it's not a decrease. So this statement is false. And number 9, the function f of x equal to negative quantity x plus 6 quantity squared plus 4 represent f of x, and the graph represent g of x. So before we can do all those 3 bullet points, let's graph the function f of x first, right? So here we know that our vertex is negative 6, 4. Okay, so the negative 6, 4 is here. So let's do a rough sketch of our function f of x. Right, kids? And so for g of x, the vertex for g of x is also at this point, and notice how they are at the same height. So this point is negative 6, 4. This point is negative 2, 4. Okay, so determine true or false for each statement. For bullet point number 1, the line of symmetry for g of x is at x equal to 2. Well, if we look at the graph for g of x, this is our line of symmetry. So this is x equal to negative 2, not 2. So this is false. The value of x when g is greater than the value of x when f of x is at its maximum. So then the maximum x value for f is negative 2, and for g is for f of x is negative 6. For g of x is negative 2. That means that negative 2 is greater than negative 6. So this statement is true. The maximum of g is less than the maximum of x. So we know that the maximum of g is 4. The maximum of f is also 4. So this statement is false. Okay, and for number 10, graph the set of system of linear inequalities. So then we normally graph by using the form y equal to mx plus b, right? So let's use this to solve for y in terms of mx plus b. So we have 3x minus 8 greater than 4y. Divide 4 for both sides, so we have 3 over 4x minus 8 over 4 greater than y. So we have 3 over 4 minus 3 over 4x minus 2 greater than y. So let's graph this graph. So from here we know that our slope is 3 over 4 and the y-intercept is 0, negative 2. So let's start from 0, negative 2 here on our graph, and we go up 1, 2, 3 and write 1, 2, 3, 4. And now we have our graph, and then is greater than, we have our dotted line, right? And it's less than, we shade in below the graph.
Can I go through?
Okay. And then the next function is, so I'm going to change a different color for our next function. So this is y is greater than negative 3x plus 5. So then the slope for this function is negative 3 over 1, and the y-intercept is 0, positive 5. Right? So then we go up to 5, put a point there, and negative 3, 1, so that means we go down 3, so 1, 2, 3, right 1. And then it's also a greater than, so we have a dotted line. And we're shading above our graph. And notice that we have the blue and the red intersect at part of the graph. Okay, so then we see that where the intersect is our answer for number 10, but it does not include the lines, and the lines are dotted. Okay, number 11. A car is tested to determine the speed at which the car achieves the greatest gas mileage. The quadratic model created to fit the experimental data is given by f of x is equal to negative 5.02 plus 1.50x minus 0.03x squared, where f is the gas mileage in miles per gallon and x is the car's speed in miles per hour. What information does the quadratic model provide about the car gas mileage? Select the correct statement. So before we can answer A, B, C, and D, so let's work it out first. Right. Okay, so we see that let's rewrite this function f of x in its standard form. So we have 0.03x squared plus 1.5x minus 5.02. Okay, and for this one, well, since they're looking for the maximum mileage, we can try to find the vertex, right? So for this equation, let me move it down here. So then the vertex for this form is x equal to negative b over 2a, right? So from the equation, we know that a is equal to negative 0.03 and b is equal to 1.5. So then that means that x is equal to negative 1.5 divided by 2 times negative 0.03. So when we work this out, this gives us 25. Okay, so here we're saying that when the speed of the car is at 25 miles per hour, we have the maximum gas mileage. So then to find out the maximum gas mileage, f of x equal to negative 0.03 25 squared plus 1.5 times 25 minus 5.02, so the answer come out to be 13.75. Okay, so then based on those information, we can go back and answer our question, right? So we say that our vertex x equal to 25 and the function is equal to 13.73. That look kind of messy, so let me rewrite this. So x equal to 25, the function equal to 13.73. Right, so see that what information does the quadratic model provide about the car's gas mileage? Select the correct statement. So the car gas mileage is capable of being greater than 13.73. So we see that this is our max, so it cannot be greater than. So this statement is false. The car gas mileage is greatest at the speed of 25 miles per hour, right? So we see that the greatest mileage is at 13.75 at 25 miles per hour. So this statement is true. The car gas mileage decreased after reaching a speed of 13.75 miles per hour. Well, we see that this number represents the gas mileage, not the speed. The speed is 25, so this statement is also false. And for D, said the car's gas mileage increased at the rate of 1.5 miles per hour per gallon for every mile the car increased in speed. And this is not true, so this is also false.